Hello there, geographers. This is what I want you to do for the holiday break. So it's not that much really. This is the part of syllabus that this work is related to, and it's about the atmosphere and change. More so atmosphere than change at this stage. Because it says that describe the function of the atmospheric system in the terms of the energy balance between solar and long-wave radiation. Explain the change in this balance due to external forces, changes in solar radiation, changes in the bead of the atmosphere, and changes in long-wave radiation return to space. So that's really what I would like you to do now. And much of that is it's related to the normal sequence of things happening in the atmospheric system. And you can find information about that on page 100 to 104 in Planet Geography, and answer the questions on page 104. This next question is a past exam question, and it explains the relationship between atmospheric greenhouse gases and the temperature of the Earth's surface. So this is what a typical IB question would look like. So by all means, use that as well. But in short, what happens here is that I would like you to be aware of really what happens on the planet when it comes to the composition of the atmosphere. I've shared a document with you as well. It's found here, and it's also, as I said, shared with you. But it's about the atmosphere, which is roughly 500 kilometers thick. Everything that really matters when it comes to climate and climate changes happens here in the troposphere. 99% of the atmosphere is found here in the lowest 40 kilometers. So everything, weather happens in the troposphere. But in order to be better acquainted with the atmospheric system, look up page 100 and 101, fill out the documents. What are the characteristics of the different layers, i.e. the exosphere, the thermosphere, the mesosphere, the stratosphere, and the troposphere? So what happens here? So you should be aware of that. So that's one of the aims. Next aim is really to understand how the natural greenhouse effect work. The natural greenhouse effect is exactly what it sounds like. It is something that happens naturally, and without greenhouse gas, there wouldn't be any living creatures on the planet, because it would be too darn hot. So basically what it is that it's a layer composition. The composition of this layer is of greenhouse gases, which can be seen in the photo here. So the energy that that this Earth receives from the sun radiates towards the sun, and of course is in a way, some of it bounces off directly, but most of it reaches the surface of the Earth. But that specific bounce, when that specific bounce happens, the wavelength changes, and it turns from ultraviolet into infrared energy. Heat. Some of the heat is of course radiated back into the space again, but much of it is trapped underneath this layer of greenhouse gases. And the most important greenhouse gases are water vapor, carbon dioxide, and methane, and nitrous oxide. And without this layer, there would be no life on the planet. So that's the natural greenhouse effect. But basically what happens then is, if what's important for us as well to understand is the human enhanced greenhouse effect. The increasing amount of carbon dioxide in the atmosphere as a result of human activities, burning of fossil fuels, for instance, coal, oil, and natural gas, which releases carbon dioxide into the atmosphere. And of course, the cutting down of the tropical rainforest releases a lot of carbon dioxide into the atmosphere, because of course the rainforest itself is a carbon dioxide sink. Carbon dioxide is stored in the tropical rainforest. But what happens then is, of course, that when that greenhouse gas is ejected and released into the atmosphere, the layer becomes thicker. The layer of the greenhouse becomes thicker. So less heat escapes into space and more is radiated back again to the surface of the Earth. So more of the heat stays within the atmosphere and does have an effect on the planet. So that's basically how it works. Some of the greenhouse gases are CFCs, for instance, chlorofluoride carbons, which are used in aerosol sprays, which is also an important one and do have an effect as well. So at this stage, we're not going to look so much at the effects. That will be done when we return after New Year's. But of course, it does have an effect on the weather. We see milder winters, but wetter winters, warmer summers, temperatures peaking, rising sea levels. It will have an effect on farming. It will have an effect on the water. The oceans are getting saturated of acids. Can't receive any more acids, and of course that will have an effect on everything from any aquatic life to us, of course. But that is something that we'll be returning to at the end of after New Year's. Yeah, that's it really. Take a look at the atmosphere. Take a look at the also the natural and the man-made greenhouse effect, and read 100 to 104 and answer the questions. Good luck. If you have any questions, don't hesitate to email me. Merry Christmas and a Happy New Year.